We will continue the discussion on email probably and Twitter and support channels. But yeah, real pleasure. Thanks for participating in Map 2020. And we look forward to continuing a lot of these projects around the world.
Thank you, Eduardo, and thank you for the Mapillary team for the wonderful project and activities around the globe. And everyone, I just want to remind you that you can also reach out them by email at osm@mapillary.com. And now we are entering the next fantastic talk by Sajjad Anwar from Development Seed. Are you ready, Sajjad?
Yes.
Okay, so please take it away. Thanks.
All right. Hey, everybody. My name is Sajjad. I work for a company called Development Seed. I'm really excited to be here. It's been incredible to watch the HOT team put together such an incredible show. So I can't thank them enough. Yeah, and I hope wherever you are, you're staying safe. So the next 18 minutes or so, I'll try to talk about one of my favorite projects at Durham Seed over the last couple of years, and kind of walk you through what we've done and some of the reasons why it might make sense for more partnership and wider impact within OSM itself. Yeah, so we could go to the next slide. So like I said, I work for a company called Durham Seed. I've been mapping and building tools for OSM for a little over a decade. Development Seed has been around for almost 17 years now, and a lot of what we do is support partners and organizations use Earth data and vector data to understand human footprint, run campaigns around human rights and health and all kinds of different things, including climate change and climate science. And OSM has grown to become quite a core part of our work. And early on, we used to spend a lot of time building tools for OSM. So if you look at ID, for instance, kind of started with a couple of people who were part of Durham Seed back in the day. And now it's grown to a point where we're kind of building tools for our partners to continue to take advantage of the incredible amount of data that's within OSM, and also support people kind of get onboarded into the OSM community and the ecosystem at large. So I want to talk about one of those projects, which we call Observe. We can go to the next slide. So Observe isn't something that's new. We started Observe in 2017 with an organization called Digital Democracy and World Bank, and started building out what looked like an app that would allow you to kind of capture additional data to existing OSM points or features that exist. So you could go out in the field and then capture additional tags that may or may not belong directly within OSM, or tie additional surveys and things like that to existing data in OSM. And this is a great idea, because a lot of times we come across data that we want to collect, but they don't necessarily belong in OSM. So the project didn't unfortunately go very far because some of our technology choices weren't sustainable back then. And then in the last couple of years, we've been working closely with groups like Maxar and World Bank to kind of revive this and actually build something out there. So the result of what the last couple of years of work is what we have as Observe. Now, I want to take a minute to kind of quickly talk about sort of why this matters, and then sort of discuss a little bit about the current ecosystem of mobile tools in OSM, and also kind of our reasoning of why do we have to build another one while there are many other existing tools. So if we go to the next slide, especially with HOD's new ambitious and audacious project in the grant, one of the core theme is to improve local mapping and also kind of empower local communities to kind of contribute to the map at a higher quality. While remote mapping is kind of like primarily driven quite a bit of the data into OSM and also building the community, there's a lot that is kind of comes as a limitation of remote mapping. and we've kind of realized this quite a bit with several partners when we try to encourage people to do a lot of remote mapping. You can only really get a certain level of map fabric with remote mapping, and a lot of the additional data you have to have people on the ground doing field surveys to get to that point. Now, doing field surveys is not cheap. It's not easy. It involves a lot of training. It requires people to be quite persistent, depending on the weather and the traffic and a lot of different things. You always have devices failing on you. You have issues with battery and internet and all kinds of stuff. So it requires a very high level of comfort and sort of a high degree of patience to be out there in the field to collect data. It also requires a certain number of people to be committed to doing something like that, which is, you know, which is to kind of go out together, sort of undertake a certain size of field mapping to cover a pretty large amount of ground. And it's very hard to do as one person. I mean, you could spend time doing that as one person over a period of time, but it's better if you go out as a team. So that requires a certain amount of effort as well. The second part of sort of local versus remote is also, when we go to the next slide, is the question and the balance between validation and mapping. I think, you know, there's a lot of emphasis on validation and building validation tools and pipelines within OSM now, which is really cool. And I've seen that kind of grow in the last maybe 4 to 5 years. And sort of the underlying thinking that any data isn't that great. You still need to have good data and, you know, not potentially kind of throw people off by giving them bad data. And I think there are several aspects of validation. You could obviously do a lot of kind of geometry level validation. You can catch typos, make sure the tags are valid and things like that. But there's, in the end, the physicality and the existence of certain data points need to be verified, and that can only happen locally. So both actual field mapping and field verification has to kind of exist in OSM, and I think it's becoming more important than ever for us to kind of shift our focus a little bit more into doing local mapping. And a lot of the speakers just before me talked a lot about building local communities and running mapathons and training. And I think that's kind of the direction that OSM is moving further and further, and not just kind of encouraging people to join the project and, you know, do remote mapping. So I think if we go to the next slide, so that kind of presents an opportunity for us to now start thinking about the tools that exist within OSM that supports this type of local mapping workflow. Now, if you speak to a very experienced OSM mapper, they have their own workflow. They've been thinking about this for a long time. They have their own favorite GPX tracker. They have their own favorite picture app. They bring a notebook and a pen. They, you know, set out. They have a very set workflow, perhaps not so rigid, because flexibility, being flexible out in the field is also one of the core aspects of being a good field mapper. But some of these knowledge, especially how to interact with these slightly cumbersome apps, is quite hard to transfer or to sort of onboard new people. Now, if you look at the editing history in OSM, and the tipping point for like a drastic growth in the number of people who joined OSM was really when ID came out. Not that until then people weren't mapping. People were mapping, the project was really going well, and there was a great ecosystem of tools. But when ID came on board, it was so easy for people to join the project and start making their first edit. It was less intimidating. You know, it was a very familiar interface. People could just quickly start mapping. I think we're kind of waiting for that moment in the in the mobile tool ecosystem for OSM. I think Maps.me was that for a little bit until kind of they changed course. So if we can go to the next slide. So the OSM wiki does relatively great job of kind of capturing all the existing mobile tools within OSM and try to compare different features and the availability across different platforms and things like that. And we spent quite a lot of time talking to people who were using these apps and also trying some of these out, and realized that field mapping is still quite a huge learning curve. It not only requires you to have a certain level of mindset and patience, the tools require you to learn and perhaps also relearn quite a lot of the workflows of mapping outside. So you kind of see an array of tools. You see tools from Street Complete, which are very specific for validation and verification. Then the other spectrum is Vespucci and GoMap, where you have full control over editing all geometries. And then somewhere in between, there's Maps.me and OSM and where it is kind of a navigation app, but it also allows you to add points, but it has a slightly larger learning curve, and you have to kind of get used to that workflow. So we wanted to build something that's familiar in terms of interface. We wanted to build something that has the same workflow on both Android and iOS. We wanted to build something that's easy for people to sort of install and get started. It should be easy for other people to train. It should be easy to work as a team. So that's kind of some of the reasons why we built Observe. So if we go to the next slide. So over the next couple of slides, I'll just run you through what we have so far. So I gave a similar talk last year in Heidelberg, and since then we've built a lot of interesting things. So it'd be good to kind of talk about those really quickly, and then sort of think about what the future of the project itself would be. So Observe works both on Android and iOS. It's open source. We encourage everybody to sort of fork and build custom versions and so on and so forth, but also kind of start using and see what we can do better. If you go to the next slide, you can actually skip the next one and go to the next one. So one of the core things that so a lot of Observe's design philosophy has been borrowed heavily from ID. So, starting with presets, for instance, is we kind of stick to the same preset format. So you can expect everything that you see in ID as part of Observe. So there are no surprises there. You search through presets, it'll try to recommend some of the presets that you've used before and so on and so forth. And this allows you to build custom versions of Observe that for things that you actually care about. So you only care about trees, you can build a version of Observe just for trees and send it to the group of people that you want to go out there and map. Now, customizing presets is super important, especially in the field. It's because you want to be very careful about people guarding against people making accidental mistakes to existing data. So if you can kind of like safeguard by saying like, hey, look, I'm only interested in these 5 or 8 presets because that's the focus of this mapping exercise, that buys you quite a lot of room to, that guards you against people kind of making accidental mistakes by changing presets that are not interesting. Of course, there are questions about how these changes affect the topology of the map and so on and so forth, and we'll talk about that in a minute. If you go to the next slide, from the get-go, we wanted to make Observe work offline. So this means that you would kind of set up your environment before you go to the field, unless you have a 4G or a 3G connection while you're out in the field, which can be quite unreliable and spotty in different parts of the world. So you could download sort of different data packages. So you go to the map, you say, I want to download this area. When you download, it downloads the OSM data, it downloads the map tiles, and it also downloads the satellite imagery tiles. So you have all of these 3 things offline while you're in the field. And you can have different offline map locations to sort of like guide you through splitting the area or the task that you're interested in mapping. Go to the next slide. You know, a lot of this looks very much like any other map app. So it's a very familiar interface. You have a drawing tool, then you get to pick the preset, and then you save your changes. So it's pretty straightforward that way. You can, in the next slide, you'll see how easy it is to kind of like add or edit attributes. So you just select the feature that you want, click on edit, and then you kind of inspect what's there. Go in and add additional tags if you want. So last year around this time, we only actually had the ability to add points or edit geometry of only points. Now, on the next slide, you'll see since then we've kind of added capabilities for you to add and edit way geometries. So in this case, I'm drawing kind of an alley there. And in the next slide, you will see kind of being able to edit ways. So, you know, you can expect standard operations like moving nodes, deleting nodes, merging them, and a lot of kind of like basic operations that you want to get to edit geometries. Now, editing way geometries is a quite sort of a complicated workflow, regardless of how well the user interface is designed, because you're in a small screen, you're trying to do something really quickly because you want to move on. So there's always that limitation with editing ways, and we've tried to get it to a point where that it doesn't try to do anything automatically. It tries to tell you exactly what you can expect, and then you decide whether that's the right course of action. One of the things that we did, especially with adding and editing POI geometries, is kind of basic conflict management. So in the next slide, I thought we'll talk a little bit about that. It primarily means that, you know, especially when you're offline, it's possible that people have changed the feature that you're editing before you had the chance to upload your edit. So you get within the app, you get to see what the changes made by the people previously, and then you can decide whether you want to kind of keep your change or throw it out, or, you know, inspect that on a desktop app like ID or JAWSM. Two kind of core features that we had a lot of requests from after our conversations in Heidelberg were, one, recording GPS traces, and two, being able to take photos as you go along in the field. So in the next slide, there's kind of a GIF of how you can record GPS traces. It's pretty straightforward. You just turn it on and then keep walking or continue doing your mapping work. The way you can use these GPS traces, the next slide, we've built sort of a accompanying web dashboard where you can see the traces that you recorded with the app, and then you can export that directly into JAWSM. And I have 1 minute left. So so in the next slide, you know, we'll talk about how you can take photos and do the same thing with photos to kind of use that for mapping later. Usually people do this if they want to take a picture of like the sign of a store and then come back and type in the name later on. You can actually skip the next slide where, you know, we show how you can download. So a lot of this is entirely built on React Native and Mapbox.gl, which has been, for me personally, has been quite an interesting learning curve. Yeah, I think in the next slide, we'll kind of briefly talk about what Observe is best for. So it's great for a field mapping workflow. You can deploy a team of mappers with minimal training because it's, you know, relatively straightforward. Quickly add POIs and edit way geometries. Also good for verifying and validating existing features. And, you know, like I talked about, you can easily build custom versions. So Where do we go from here? We don't have Observe on the App Store. So if you're checking the App Store, it doesn't exist. You have to go to the, you can just Google for Observe and download an APK or get an iOS link that you can install. I think the iOS link might actually be inactive, but reach out to me. But there are a lot of interesting conversations around how can we make Observe a bit more useful and kind of adoptable to a larger audience within OSM, and I'm excited to kind of take those conversations forward with Hot. Thank you. Sorry I had to rush through towards the end, but I'm around for questions.
Thank you, Sajjad. Thank you for the wonderful presentation and wonderful tools. So everyone, if you have really curious about the Observe, you can also directly contact Sajjad. So if you may, you can also put your contact in the chat box, Sajjad, so people can directly to contact you. So